previous class. So in the last class, we had started with electromagnetic waves, and most probably we'll end this today also. It's a very short lesson that we have EM waves. Now, properties we have already covered of EM waves. All the properties we have discussed, we didn't do any questions on this. So what was electromagnetic waves? Just in brief, if I tell you what was electromagnetic waves, so EM waves are those waves which have the direction of propagation perpendicular to electric field and magnetic field. The magnetic field will exist at a space, electric field will exist at a space. And time varying magnetic field will produce electric field, and time varying electric field will produce magnetic field. Both of them will be causes of each other. So electric field, a time varying electric field will produce a magnetic field, and a time varying magnetic field will produce an electric field. Fine. Now, after this, any wave that travels in such a medium where electric field also exists and magnetic field also exists, that wave you call it as the electromagnetic wave. Now, we discussed those two equations. E naught is equal to E naught sine kx minus omega t, or it can be omega t minus kx also. That depends. It can be variable, so you can change it. You can write omega t minus kx as well. I have told you because that minus sign has no significance with the subtraction. Minus sign simply indicates the fact whether it is along the positive axis or it is along the negative axis. Got it? So this was what we had studied. Now regarding the properties of EM waves that we have. First property is that EM, electric field, magnetic field, and the direction of propagation all are mutually perpendicular to each other. Electromagnetic wave travels with the speed of light. Then we had seen this formula is very important. C is equal to 1 by mu naught epsilon naught. Mu naught is your permeability that you use in magnetism, whose value is 4 pi into 10 to the power minus 7. On the other hand, you have permittivity of free space. So permittivity of free space is what? 8.85 into 10 to the power minus 12. And this is just for free space. Then if you have a medium, just multiply mu r along with epsilon r, mu r and epsilon r. So ultimately, when you will solve this, you will be left with C divided by 1 by under root mu r epsilon r. This is rarely asked in the exam and other medium to calculate the other values, but it is not a unique question. It can be asked. So there are chances that this question can be asked. Refractive index we have done is equal to under root mu r epsilon r. All optical phenomena are due to this. We'll study in case of optics when we do. The next chapter is your ray optics only that we'll start with. Now see energy density. See, energy density is basically energy per unit volume. Whatever is the total energy that you have divided by the volume that is present, that is known as the energy density. So energy density is what? Energy density is the energy per unit volume. Energy divided by the volume. Simply you can say in short terms. Now energy density, the total energy that is comprised in this electric field and comprised in this total electromagnetic field. It is either due to the electric field that is present or it's due to the magnetic field that is present. So if it is due to the magnetic field, that we'll call it as the magnetic energy. If it is present due to the electric field, then we say it is the electrical energy that exists. Now, electrical energy we have already seen and discussed in when we were doing. So in electrical will be half permeability. It will be half, will remain. Instead of permittivity, you will have permeability. Now, permeability is what? Permeability will get divided. That is your magnetic permeability. That will get divided. Here it is in the multiplication. That time it will be in the division. So, half B square divided by mu naught. Both the energies are here. Now, these values are the RMS value that you have. So when you'll combine the net energy that is present in the system, that will ln naught E square plus half B square by nu. If you want to find it out in terms of peak value, everything will remain the same. Just instead in the denominator, you will have 4 because your RMS value is peak value divided by root 2. So when you square it, so peak value square divided by root 2, it will give you what? Root 2 square will give you 2 only. So 2 multiplied by 2 will again give you 4. So that's why it's nothing, no change is there except for the fact that instead of RMS value, you have the peak value, and instead of the denominator as 2, you have the denominator as 4. This is the change that occurs. Now, for momentum, in case of momentum is total energy, whatever is the total energy that is present in the system divided by the speed of light. So if it is for an absorbing surface, means the surface is there where light is absorbing. So that will be P divided by T. Simply formula of momentum you can say, or you can even say formula of the force, or the definition of the force also. If it is reflecting, means a light has struck the surface. Now the light is reflecting back. So if you're talking about this case, when the light has arisen on the surface plus when the light is going back, then momentum will become twice. Twice how? Because of the sign convention, anything gets doubled whenever we are referring to it. So that is 2p divided by t. Intensity was the last topic that we had discussed. Intensity is energy per unit area per unit time. Now C class, I don't know whether I have mentioned this fact to you in the last class or not. Last year, when we had this 12th class board examination, that time some of the topics got deleted. Last year also there were certain changes. So in electromagnetic waves, displacement current and all those Ampere's law, all these topics were deleted. This time these topics have been added in your syllabus. The displacement current, not in detail, not in much detail, but briefly these have been added in your syllabus. If they are added in your syllabus, there are a lot of chance that questions can be asked from displacement current. Displacement current I will do. Let us do 1 or 2 numericals at least on this topic. At least let's get familiar with the equation that we have. So regarding your displacement current, why I'm saying, because displacement current was deleted last year, so no question was asked from it. Even last year no question was asked from it. So if you are getting a topic that has been recently or freshly added, so chances of coming that topic are greater. So please pay attention. I think the chances of displacement current coming is more, and you do not have it in detail. Earlier it was in detail, done in detail. That was the core part of EM waves. That has been deleted. That has been reduced. For you people, it has been reduced, but not deleted. So we'll do that. Let's practice certain numericals. This question, we have discussed the formula for this. You just have to find out magnetic field. Electric field is given to you. See how this question will be solved. You have the value of magnetic field with you? No, not magnetic field. Magnetic field has to be calculated. Electric field is given as 6.3 J cap. Leave J cap for now. Right now, just focus on the magnitude. Magnitude is what? 6.3 into 6.3. Fine. Now, if you take the ratio of electric field and magnetic field, we had discussed this in the second property when we did. So ratio of electric field and magnetic field gives you speed of light. So this is known, only this is unknown. Magnetic field will be what? Electric field divided by the speed of light. Magnetic field, electric field is what? 6.3. Speed of light is 3 into 10 to the power 8. 2.1. 2.1 into 10 to the power minus 8 Tesla. This will be your magnetic field. Now see, electric field is along J cap. Electric field is along J cap. And the wave is propagating along, some axis is written, along x-axis. Wave is propagating along x-axis. This is the direction of propagation. Can anyone answer what will be the unit vector that will come along magnetic field? Salman? Unit vector that will come along magnetic field? Which? Which vector, Salman? See, okay, network issues. So just type. It's okay if you can't. Just type me whatever you were answering. No, I couldn't hear it. Just type it. If your direction of propagation is along x-axis, your electric field is along y-axis, then in which axis or along which unit vector will your magnetic field exist? Memona? Khalid, can you answer this?
Teacher, I cap.
I cap means x-axis. So direction of propagation is along x-axis as well as the magnetic field. Sneha, how it will be I cap, Salman? Direction of propagation, electric field, magnetic field. What was the property that we have discussed in the last class? All these three are mutually perpendicular to each other. So if electric field is along J cap, direction of propagation is along x-axis or I cap, then which vector, unit vector is left so that it is perpendicular to both electric field and direction of propagation? Which axis is left? K cap. Yes, Samira, it will be K cap. Because your electric field's direction is given, direction of propagation is given, and all these three are mutually perpendicular to each other. It's not electric field and magnetic field are just perpendicular to each other. They are also perpendicular to each other as well as to the direction of propagation. So if they are mutually perpendicular to each other, then how can you say that electric field is along the direction of propagation is along x-axis as well as the magnetic field? Direction of propagation is along x-axis. Electric field is along y-axis. Then magnetic field will be along z-axis. Got it? So here, this will be K cap. Note it down. We'll do 1 or 2 questions. See, just compare it with the main equation that you have. Yesterday we did, no, day before yesterday we did those equations, no. The main equation, B is equal to B naught sine kx minus omega t plus minus omega t. Compare it with that and then try to find out wavelength and frequency.
From here.
3.14 as the wavelength. No, it's slightly more. See, I think you have not included pi. 3.14 is the value of pi, no? The equation that is given to you is what? By is 2 into 10 to the power minus 7 sine 0.5 into 10 to the power 3 x plus 1.5 into 10 to the power 11 t. Compare it with the main equation. B is equal to V naught sine kx plus omega t. Can you compare it? Now for wavelength, k is equal to 2 pi divided by lambda. So yes, Sneha, what is the formula of k? What is k given in this equation? Can you identify k? Yes, Sneha. Just compare both the equations. What is the value of k? Angular wave number. Sneha, you're there in the class? Yes or no? Yeah. See, Sneha, k will be this part. Kx omega t. So lambda is asked, so it will be 2 pi divided by k. This becomes 2 into 3.14 divided by k is 0.5 into 10 to the power 3. So 4 into 3.14 will give you 1.26. Okay, I was asking you what is k. So k will be this part. I was asking you this. This will be 1.26 into 10 to the power minus 2 meters, you can write. Or you can even write 1.26 centimeters. So that will be the way. Just check, Samira. You were getting just this part. I think some calculations error must have been committed. Expression for electric field. See, if magnitude of magnetic field is given, we can easily find out the magnitude of electric field. Electric field will be what? C multiplied by B naught. So 3 into 10 to the power 8 multiplied by 2 into 10 to the power minus 7. This gives you 6 into 10. That is 60. So we can write the equation as EY. Now peak value will be what? Wavelength is 12.56 into 10 to the power minus 3. Frequency is 23 into 10 to the power 9. Oh yes, frequency was also asked, no? How much you're getting? 23 into 10 to the power 9. It's correct, it's correct. Right, Khalid. Both the answers are correct. Okay, I forgot to solve frequency. Wavelength and frequency was also. Let's complete this part, then I will find it. Peak value will be 60 sine. Now repeat this whole term as it is 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t. This becomes equation for Lect. For frequency, see frequency is what? Omega is given, frequency omega is 1.5 into 10 to the power 11. Frequency is 2 pi nu. 2 pi nu is omega. So this will be omega divided by 2 pi. Omega is 1.5 into 10 to the power 11 divided by 2 into 3.1. So frequency will be what Khalid is getting, 23 into 10 to the power 9 hertz. Just note this down. See, Ampere's circuit law we have already discussed. Do you remember Ampere's circuit law? What was Ampere's circuit law? Khalid?
Yes, teacher.
Ampere's circuit law. What was Ampere's circuit law?
It states that the line integral of magnetic field is magnetic field over a closed loop or path is nu zero times the current threading over it.
Yes. So line integral of magnetic field, that is B dot dl. This is equal to mu naught times the current that is flowing. Fine. Now there was certain inconsistency of this Ampere circuit law that was observed by Maxwell. So what did he do? He chose two paths. These are the capacitors. Capacitors. He took one closed loop as C1 here and another closed loop as C2. C1, C1 and C2 were the closed loops. Now, when the circuit was conducted, when the switch began, then what happened? C1, if you choose the loop, current will flow through this. There will be a particular current that will be flowing through this. Let's say I1 is the current that is flowing. If I1 is the current that is flowing, so if I just talk about this loop C1, so C class, in this loop C1, what is happening? B dot dl across this C1 will be what? Mu naught times the current enclosed, right? But if I talk about C2, see, there is no current flowing that is present within the gap of the two capacitors. If the two plates of the capacitors are there, there is not a presence of current in it, because between the two plates of capacitor, current will not exist. So B dot dl for C2, this will be mu naught multiplied by 0. So, is it consistent with Ampere's circuit law? According to Ampere's circuit law, for any loop, for any closed path, for any particular point, B dot dl is equal to what? That is equal to mu naught times I. So, here what is happening? Here there is an inconsistency that we can obtain. So, Maxwell did what? He modified the equations of Ampere's. So to modify the Ampere's law, Maxwell followed a symmetric conservation. He changed the loop and he got a current that was associated with it. And that current that we obtained, he called it as the displacement current. So what is displacement current? Let us just focus on displacement current. So background has been obtained from the experiment done by C1 and C2 loops. Now, what is meant by displacement current? Conduction current is the current that occurs in space whenever a circuit is connected properly. Like in a circuit, when the terminals are connected to the ends of the battery and the key is tapped on, then a current flows in the circuit. That current is known as conduction current. And when any other current exists in space apart from that conduction current, we call it as the displacement current. So here also, displacement current is what? It is the current which comes into existence in addition to the conduction current. But there is a condition, because any other current that is existing apart from the conduction current, we cannot call it as the displacement or a specific current. Why are we calling this current as only as the displacement current? Because if this exists in a particular electric field, so which comes into existence in addition to the conduction current, whenever the electric field, first point, whenever electric field, and therefore what will be associated with electric field? Electric flux. So whenever electric field and electric flux changes with time, whenever electric field and electric flux change with time. Now, to maintain the dimensional consistency, the formula that he gave, you don't have to go into the derivation of the formula. All these formula, these were done experimentally by Maxwell at his time. Now, you just have the final formula with you. Formula of displacement current is epsilon naught. Epsilon naught is what? The permeability. And the rate of change of electric flux. This is the formula of displacement current. Epsilon naught is what? Permittivity of free space. ID is what? Displacement current. This is rate of change of electric flux. Rate of change of electric flux. Now, total current across the loop will be what? See, one current is already there that is existing, which is your conduction current. Conduction current we have already studied, that is your direct current that is present in the circuit. So total current will be what? Total current across the loop, this will be displacement current plus the conduction current. Now you have the I enclosed with you. This is the I enclosed. Now you can write the modified Maxwell Ampere circuital law. So line integral of magnetic field is mu naught times the total current that is enclosed within the circuit. This is the modification that Maxwell has done in the Ampere circuital law. So B dot dl integral, you can write it as mu naught IC plus displacement current. Just now I have told you this is epsilon naught d phi over dt. These two formula are very important. So this is now your modified Ampere circuit. There's a proof also. If you wish, I can tell you the proof also. In proof, what we do? See, now I'll tell you. Let me tell you. How is it now consistent? Consistency of modified Ampere's circuital. Sorry. This will be circuital. Ampere circuital law. Now see, across C1, this will be B dot dl closed integral is equal to mu naught I. Now across C2, this will be what? B dot dl will be equal to what? Mu naught times that current that we have, displacement current, whose formula is epsilon naught d phi over dt. Got it? Here this is conduction current. This time it will be displacement current for C2. Why we are calling it displacement? Displacement term is used, no? Because this is due to the drift of the electron. This is caused by the drift of the electron. That's why we name this as displacement current. you see, electric field is what? Electric field is Q divided by epsilon naught A. Sigma by epsilon naught. No, we did it for a plane sheet. For area of a capacitor, if you refer it to, that will be E is equal to Q by epsilon naught A. So EA will be equal to Q divided by epsilon naught from Gauss theorem, just inverse steps of Gauss theorem that we did. So flux will be equal to what? Flux is equal to Q by epsilon naught, which you already know. I'm just revising these here. These are not necessary. Since we are doing a proof, and proof you have to prove all the steps. That's why. So phi E means phi electric will be Q by epsilon naught. Now put it. B dot dl closed integral for C2. Put it. This will be mu naught epsilon naught d phi over dt. So mu naught epsilon naught d phi over dt. This will be Q divided by epsilon naught dt. So epsilon gets cancelled. Charge divided by time is current. So you are getting mu naught I. So this time B dot dl closed loop C2. This is also mu naught I, and your B dot dl closed loop for C1 was already always this was mu naught I. This shows now they are consistent with each other, and that inconsistency that was created by amperes that has been resolved and solved by whom? Maxwell. So we call this as modified Ampere circuit law. This is known as what? Modified Ampere circuit law. One last thing before you note down these, certain properties are there for displacement current. Properties of So first property says that it does not exist in steady conditions. It exists whenever there is a change in electric flux. Displacement current exists only in change of flux. Second point, it is actually not a current if you see. This is what we call it as a current because it adds to the current densities Ampere circuit law. Technically, if you see, this is just drift of electrons. So it is not a current if you see. It is just drift of electrons that are occurring. It is just current density. It produces magnetic field. That's why we are calling it current. So it not you can write it produces magnetic. It produces magnetic field. Third point you have to remember that the magnitude of displacement current, this is equal to the displacement of charge. Displacement current's magnitude you can say, the strength you can say, this is equal to is rate of displacement of charge, rate of displacement of charge from one plate of capacitor to another. From one plate to other. Last property also you can remember that it satisfies the property of continuity. So this satisfies property of continuity. Certain points are there. These are just theoretical points. I don't think so anybody is going to ask you the properties of displacement current. What you have to remember mainly and what are maximum properties can be asked if the paper is tough. Otherwise, see, this part is important. Till this. mu naught IC plus epsilon naught d phi over dt. Till this part is very important, that the total current produced across the loop, this is ID plus IC, and why are we getting this modification? Because of this inconsistency that was occurring because of Ampere's law, that one across one loop of the capacitors on the left side of capacitor, the Ampere circuit law gave you mu naught I, but on the other side between the plates of capacitor it was zero. Got it noted down from here. But remember, till here these portions are important. If you have any doubts, you can ask me. I'll repeat any part if you want.
Teacher, could you like explain the proof again
Which part,
in
Khalid?
the this one consistency of modified Ampere?
Yes, yes, I'll explain. This part is clear. There is an inconsistency. Now, when this component of displacement current got added, no, when this component of displacement current got added, means epsilon naught d phi over dt got added. So what happened? This existed and this was done experimentally by Maxwell. He did what? He combined two loops together across the capacitor and he connected the wires along the battery, the terminals of the potential of the cell and all these. He conducted a circuit and he obtained that the magnitude of displacement current, just a term displacement as current is given because of the drift of electrons. So this type of current that is present apart from the conduction current, this is directly proportional to rate of change of magnetic flux. Fine. So this was obtained. Now, how to show whether this is consistent and not Ampere circuit law wasn't okay? Ampere circuit law's equation was not consistent. We understand because we have seen across C1 it is mu naught I and across C2 it is zero. But how can we agree with the fact that this displacement current is providing a consistency to the Ampere circuit equation? So if you just solve this further, this is clear, mu naught IC plus epsilon. This is actually total current. See, across C1, this is mu naught I. So across C2 also, if somehow we try to bring this as mu naught I, we'll be able to prove the fact that both are consistent because both are equal. So here what will happen? C2 will be equal to what? Electric field, or directly you can say flux is equal to what? Q by epsilon naught. In the main equation, mu naught epsilon naught d phi over dt, put d phi instead of phi, put Q divided by epsilon naught. So epsilon naught from the displacement currents equation and epsilon naught that has recently been added because of electric flux will get cancelled. We will be left with mu naught Q by T. Q by T is current. So we are getting what? Mu naught multiplied by current. This is for the second loop. Now we are getting mu naught I. And for the first loop, we always had it as mu naught I. So now they are consistent. Both are equal. So it means that yes, displacement current was necessary. This formula was required. Now we can say and we can conclude the fact that yes, both the loops are now having the same Ampere circuit law, and that is valid for both of it. Did you get it, Khalid?
Yes, teacher.
Okay, so please note it down, all of you. If you have any doubts, anybody, you can ask me. I'll repeat it. Till here, this part is important. The portion I've repeated just now, this is important. Other things are just extensions of it. Properties, I have never seen a question of displacement currents properties come. Properties are generally asked from that spectrum. But yes, you have to, I have written it on the screen so that you can revise it once. Just in case if it comes, you should not lose your marks.
Ma'am, can you please scroll a little up?
This much? This much you're asking to scroll up, Sumaira?
Yes, ma'am. Ma'am, you can scroll down now.
See class, this question says a parallel plate capacitor has circuitous plates each of radius 5 centimeters. It is being charged so that electric field in the gap between the plate rises steadily at the rate of 10 to the power 12 volt per meter per second. Whenever I use the word rate, I have told you that rate means anything that gets divided by time or anything that changes with respect to time. So dE divided by dt is given you 10 to the power 12. Now radius is also mentioned 5 centimeter. Let's convert it into the SI unit. 5 into 10 to the power minus 2 meter. This is the radius given. We have to find out displacement current. So this is epsilon naught d phi over dt. Now epsilon naught d phi E we can calculate it. This is electric field multiplied by the area, or you can say electric field into pi r square. Just put in the value. So ID will be equal to epsilon naught E A, not A, pi r square. Instead of area, I'll write pi r square. This will be pi r square dt. Now, electric field over time is already given as 10 to the power 12. So we have all the data sufficient. Epsilon naught is 8.85 into 10 to the power minus 12. dE over dt, this is 10 to the power 12. Area is pi is 3.14. Radius is what? Radius is 5 into 10 to the power minus 2 whole square. So 12 will get cancelled. Answer should come around 7. Answer is around 0.07 amperes. I remember the answer. Just check it once, the calculation. Is it 0.07 amperes or 0.1010 amperes? Just let me know. 0.1 amperes or 0.07? I think 0.07 must be the answer. So like this. So displacement current formula we have used. Just phi we have calculated using our knowledge of electrostatics. That is E into A. Got it, class? So just note down this question as well as the solution. Text me done when you have written. That class. Apart from Sumaira, only Sumaira has written. Others have also written. On WhatsApp, I have sent you a table on both the groups, girls groups as well as boys group. So this table includes the major properties of all that electromagnetic spectrum I was mentioning to you. See, these properties you have to learn. Like the frequency 10 to the power 8, just remember this order. Order that is given. Do not forget this order. First is your gamma waves. Then you have X-rays. Then you have ultraviolet. Then you have visible rays. Then you have infrared. Then you have microwaves, and then you have radio waves. This is the increasing order of wavelength, and this is the increasing order of frequency. So if the question is asked, out of ultraviolet and out of radio waves and infrared, these three are given, arrange them in order of increasing wavelength. So wavelength of radio waves will be greater than this. If, for example, a question is asked, gamma rays are given, X-rays are given, and ultraviolet rays are given. And it is asked to arrange it in the order of increasing frequency. So gamma rays, then X-rays, then ultraviolet rays. Like this question can be asked to you, so you have to remember the order. Do not change the order in which it is given. This part you have to learn it on your own. Frequency that is mentioned, wavelength that is mentioned, production, detection, and major properties. Out of this, wavelength, frequency, and major properties are most important. Fine. So you have to remember this. You can refer to this. This is exactly of NCERT summary only. But still, I suggest you to go to NCERT, open your part 1 of NCERT. All those who do not have book, open the PDF that is available on internet. Try to make out the points that are present in NCERT, because if somehow any point that is skipped in this table is mentioned in the NCERT, just in case, you should not lag that or miss that point. Fine, class. So this completes your first book. We'll have the test of alternating current on Monday. Please be prepared with the test. Any doubts you're having, you can send me on WhatsApp. You can I can arrange a class if there's any specific doubt on a specific topic that you have. All right, class. So regarding EM waves, we'll discuss this later. Let us just complete with alternating current. First, let us complete with alternating currents test. Then we'll be having the test of EM waves, as well as one test of chapter 5th is also left. Then we have complete revision test left. Like I'll be giving you portions, you will prepare from the notes, from NCERT, from wherever you want, from assignment, you will come prepared by a very small portion that I'll give you. Tests now will be conducted on a regular basis. Fine, not now. First, give the test of these individual chapters, then combination of chapters will be done. Not every day, but yes, in the class timings, it will be included. Half an hour test you all should give now, because otherwise you'll forget what you have done. Now, even I am asking you in the class, very few students are able to answer. Earlier, it was all of you who were able to answer. Everybody was active. Now, please start responding. All of you are regular. Most of you are regular. Nobody takes a leave unless and until it's emergency. Maximum of you attend the classes daily. Muna, you also be regular from now onwards. So September you have joined, so continue it only. Do not take a break now. Half yearlies, you need any help whenever your half yearlies are approaching, you can text me. I can arrange classes also, but I think now classes are not needed for you all. All the chapters for the first book are covered. If any chapter is there from the second book, then let me know. Second book is now easier to deal with. Optics is a major portion that is there. The rest of the topics are smaller and easy topics. Fine, class, I'm stopping here. Whatever doubts you have, you can text me personally also or on the group also. Okay, class, and I'm stopping. Please learn that table whenever you get time. I'm not asking you or insisting you to remember it till Monday. Till Monday, you have to prepare for alternating current first. Because till EMI, you all are well versed. All right, class. Okay then. Thank you so much. Take care. Allah Hafiz.
Thank you, teacher. Allah Hafiz.
Thank you, ma'am. Allah Hafiz.